All right, thank you very much. So I'm here to continue the PCIe party with more about how NVMe and PCIe have been a good partnership together and how that partnership is going to be getting even better as we look forward to PCIe Gen 4 and the soon upcoming PCIe Gen 5. So the agenda is going to go over PCI-SIG sort of in general and how that body works. A little bit discussion of different form factors, and then I'm going to talk about sort of where we've gotten the working together of NVMe and PCIe 3.0 so far, before going on to talk about the upcoming Gen 4 and Gen 5 specifications before we wrap up. So PCI-SIG, which is the Peripheral Component Interconnect Special Interest Group, which is a lot of words, this is why people just say PCI-SIG, is an industry consortium that has almost 3 decades of experience with interconnects. And they now have over 800 members, up from over 750 just a year ago. And part of the reason that the organization continues to grow is it continues to service more and more market segments. And it is an open organization, so you don't necessarily have to be one of the very large corporations to be a member. You can be a small company and join and get all of the benefits, which are, contributing to the specification, having access to the latest specifications even before they're released. So if you're not a member yet, you can go to the website and look at it. By the way, I am here as part of the marketing working group for PCI-SIG, just like NVMe has a marketing working group. Unfortunately, we don't get as busy meetings up to 10 people as the NVMe marketing working group gets. So if you would like to come contribute and help promote, PCI-SIG technology, we are definitely looking for more people to support that. So what are the market segments? Traditionally, people have thought of PCIe as being traditional, for PC space. That's long since evolved, looking to target artificial intelligence, automotive, cloud, enterprise, and of course storage, and all that's in addition to your sort of, maybe what you traditionally think of as your PC market segments. So how has PCIe been able to address these growing number of markets? It's because they've continued to grow and evolve the spec. So it's mostly well known for the fun of doubling the speeds. So the doubling of the gigahertz in CPUs is long since gone, but we still have the fun of doubling the gigatransfers, or gigatransfers if you prefer. So you will notice that there has been a little bit of a lag since PCIe 3.0 and the 4.0. There's not been because traditionally it's been more of a every 3 years doubling of speed, and there's a bit of a delay. But with 5.0 being quick, coming up within less than 2 years, it's going to get back on track to about that every 3 year doubling. But in addition to that, as the previous talk went over, there's additional functionality and features that go beyond just the pure performance. So another thing PCI-SIG does is they also work on some form factor specifications. So the M.2 specification for low power segments. For mainstream server performance, there's the U.2 specification, which even though a lot of people have asked, okay, so the form factor specifications aren't as far along as the base specifications of the PCI spec, so when are they going to catch up? So it's not necessary that the form factor specification match the base specification. So the U.2 form factor, that spec wasn't finalized until somewhat recently, and up through 2018, there's been over 6 million units of that sold. And it's projected that by 2020, there'll be over 20 million of those sold in the U.2 form factor. And actually, that same form factor has been used for a lot of PCIe Gen 4 early testing at some of the compatibility compliance workshops already. So even though the spec for the form factor doesn't have the same number, it still works for the upcoming specs. For high performance applications, there's the tried and true add-in card form factor that can give you, really high performance with a really high power envelope. And also in addition to the form factors that PCIe or that PCI-SIG develops, there's additional form factors that are PCIe compliant, such as the SFF TA 1002 connector-based form factors like the EDSFF 1U long and EDSFF 1U short. So these form factors allow for very high density storage with very good thermal performance. So with PCI Express 3.0 and NVMe together, they've really produced some really good benefits with scalable performance thanks to scaling the number of lanes, options for low power performance, and also reduced latency. So NVMe on PCIe has really shown us some really good benefits in the storage industry. So if we're looking at where we get some of the benefit, it's really easy to see when we have very high performance use case requirements. So if there's an IOPS per terabyte requirement, we see that SATA that hasn't really been increasing the speeds. If we get higher performance that we could get from the NAND with higher capacities, we end up getting bottlenecked by the SATA interface. With PCIe, we're able to continue having benefits from the higher capacities and having IOPS per terabyte that continues to be much better. And this is about to get even better as we move from Gen 3 to Gen 4 and also Gen 5. So since SATA really hasn't increased speed since 2008, just with Gen 3, you get a 6.5x bandwidth benefit with PCIe Gen 3. That goes to 13x with PCIe Gen 4. And then with PCIe Gen 5, which is coming up shortly, that becomes a 26x advantage. So for performance applications, you really can get a good cost benefit. And I'll kind of be going over an example that shows that later on in this talk. Now, what applications care about high bandwidth? So thanks to Tom Coughlin for the data. I know you've seen this. I assure you, Tom, there's at least 20% new content in this talk, if not more, so it is worth paying attention. So the content creation, editing, and distribution industry, they would love higher performance yesterday, because if we can build it, they can consume it. So they do not have the Kevin Costner conundrum at all. It is just, you build it, they will consume it. So with previous video formats like standard definition or even just high def TV, SATA could easily consume that uncompressed bandwidth. But as we go to ultra high def 4K, digital cinema 4K, the SATA bandwidth is no longer sufficient, and PCIe Gen 3 really starts to shine. But looking forward to 8K formats, and even looking at for immersive environments using virtual reality where you have stereoscopic, and so really you start to double the amount, you really start to need beyond Gen 3 capabilities, and the bandwidth that PCIe Gen 4 and Gen 5 is going to provide is going to be a benefit in an area like these, and there's going to be others that you can imagine. So this performance benefit has been one of the drivers of the transition of storage from SATA to PCIe, and some could debate when the crossover point from SATA to PCIe, whether it already happened, is happening soon. The point is, it's about this time where we're going from more volume being sold on PCIe SSDs than SATA. And also, the price parity is also practically there, if it hasn't already gone, where PCIe price per gigabyte is starting to get parity. And because of this, we're already starting to see the acceleration of adoption of PCIe SSDs. And as we go to PCIe Gen 4, where we get even more performance, that's only going to further accelerate. So here's an example I love, partially because a lot of people hate this example, because it is arguably just, it's a very cherry-picked total cost of ownership example. So I fully admit that you can find one that says that SATA and HDDs is a great idea. And the point is not that this is for everyone, it's just that it's important to take in all these considerations and also more. There's definitely stuff missing here. But if we're just to take an example where I need to stream 50 gigabytes of data per second from some storage devices, I would need 90 SATA drives to do that. Now, if I go to PCIe Gen 3, I only need 16 drives. And so even though each PCIe drive is much, much more expensive, because I need less drives, and I don't need as much enclosure space, and less drives means there's less things to break, so my manageability costs ideally goes down. I get a total cost of ownership benefit. If I then move to a future PCIe 4 drive, then I cut that number of drives in half again. And in this, the cost per drive estimate is pretty much fictitious. We actually made it higher, where in reality, because you'll likely have lower cost NAND in it, you'll have lower costs. So kind of try to give ourselves a disadvantage, because I know this is sort of a made-up, cherry-picked example. So try to make it as reasonable as possible. So, and we see going to Gen 5, again, doubled bandwidth, I need half the drives again. So even though my drives aren't getting cheaper, I'm still getting a benefit. So the point is not that all applications are like this. The point is that depending on your application, because of the increased performance that PCIe Gens 4 and 5 are bringing, there's going to be more and more applications that are probably going to see a TCO benefit. So even if at Gen 3 this calculation didn't work out, it's probably worth coming back to that and saying, like, is now this the time to move from maybe SATA or SAS to PCIe-based NVMe SSDs? And the answer might still be no, but it's worth taking a look again based on the new performance coming up. So what is coming up with PCIe Gen 4.0? So that spec was released in 2017, and there's been FYI testing at the compliance workshop last year. It's projected that they'll go into formal compliance testing later this year. And the reason for the FYI is very similar to why the NVMe compliance tests also do FYI testing, is to make sure that the test is valid before vendors are held accountable to pass that test in order to get listed on the interoperability list. So there's been a number of Gen 4 PHYs that have been demoed and shown at various conferences and things like that. And so it's basically here, so it's probably a matter of end of this year, early next year when we start seeing product announcements. And again, these PCIe Gen 4 hosts and devices, they're all going to be backwards compatible to PCIe 3 to all the way back to 1. And some of the added features that are included beyond just the speeds is they've extended the tags and credits, which enables for more open transactions to be out on the bus, which you could imagine if there's the latency for a transaction to get serviced doesn't necessarily change, but you're sending more transactions, you are going to have more outstanding. And this was actually done with an eye to PCIe 5.0. So a lot of this protocol work that was done for 4.0 was helpful in enabling PCIe Gen 5, which I'll be talking about soon. So again, 5.0 is the 0.9 spec is already released, and sort of the way the development of the base spec goes, it starts with a 0.3, then a 0.5, and 0.7 pretty much has the majority of what you would need in the specification, and the 0.9 revision of the spec is really just out there so that the member companies can check for any IP considerations with what is in the specification. And the 1.0 release is on target for the end of this quarter, which if you check your calendars is coming up pretty quick. And I'm told that it's still on track. So this 32 gig of transfers per second, it doubles again and again. We still get the same backward compatibility. And so what's really cool is that in the 27-year history of PCI-SIG, they started at around 133 megabytes per second. And with Gen 4, with 16 lanes, they get in single direction 32 gigabytes a second, which is about a 240x increase in performance in that time frame. And in less than 2 years, that's going to be doubled again to 64 gigabytes per second in a single direction. And the reason they're able to go so fast is because from the PHY perspective, there's PHYs that have operated at this speed. So really going from the 4 to 5, the electrical parts of it, these were solvable problems. And a lot of the heavy lifting was done in the protocol in the 4.0. There's been some slight modifications to the KIM specification to ensure for improved signal integrity. Other than that, this backwards compatibility is still completely maintained. So sort of to wrap up, PCIe 4 and 5 is going to continue the trend of doubling bandwidth every generation while maintaining backwards compatibility. And also there's new capabilities, and It's going to provide additional total cost of ownership savings for performance critical and latency sensitive applications. The NVMe and PCIe integration has benefited a number of markets, including data centers, Internet of Things, autonomous driving, machine learning, and more. So if you'd like some more information about PCIe, our marketing working group, you can check out our website. You can get on Ask Jeeves or AltaVista for PCI-SIG, whatever your latest and greatest way to find things is, or follow us on Twitter, whatever. And now if anybody has some questions that I know how to answer, I'm happy to answer them. If not, I will shuffle around them. So
on the early slides, you're talking about comparisons between PCIe and SATA.
Mm-hmm.
Now, why SATA? Why not SAS? I mean, most that I'm aware of don't really go for SATA for a performance play.
Right.
Am I wrong?
So I did give a nod to SAS here with, that there's SAS 4.0, and I admittedly this is just, for one port. I'm aware it could get up to 4 ports. I don't know how many of those in practice there are or how much is planned. But yeah, and for certain applications, like as the previous talk about, was it RASM, for the RASM, like SAS is not going away anytime soon for the applications that really need that, and I believe they're going to be around. So
you're making
together.
A comparison to a technology that's going away? That doesn't make sense to me. I'm giving you a hard time, of course. I just found it rather convenient, like, you're dead, let me go ahead and kick you a little bit more.
Just don't want there to be any confusion. We want to make sure.
No confusion whatsoever. SATA is... All right, there we go. Any other questions? Oh, hold on.
Yes.
So if you go back to your performance chart, your math was wrong. That's a by 32 column on the right.
Probably.
So you just don't want people going away with the wrong impression.
Which one's by 30? Wait. Oh, yeah.
Only for that case?
Yep.
Oh, by way. Okay.
Yeah. Yeah, that's the two. So some engineers like bidirectional. I personally don't, but I don't want to, we want to include everybody. And the reason why we use gigatransfers is to equally upset both analog and digital designers. That's
the great thing about moderation. Everybody walks away unhappy.
Yeah, I did want to comment on the performance slides you showed up there. You threw it out real quick, but you kind of glossed over it. The SAS numbers you put up there are just for one link. You showed 4 links for PCIe. You commented that you don't know how many devices are 4 links for SAS, and that's probably true. There's not a lot of companies making those. But there's a lot of external storage systems and stuff that do run 4 links. So the examples showing single link SAS compared to 4 links of PCI Express are a little misleading.
So picture 4 times the yellow bar, it's okay. So I'm speaking to the storage card, and I know in storage, by 4 PCIe is very, very common. Whereas the SAS 4 port, I didn't hear of it as being super common. So if it is, I'm willing to update it.
Just think of it this way. This is extra incentive for people to come in and help with the marketing effort.
Yeah, absolutely. Yeah.